Hello, everyone. Welcome to the Validated Patterns Special Interest Group from the OpenShift Commons series. My name is Anthony Herr. I'm the product manager associated with Validated Patterns. Wanted to remind you this is around use cases and patterns, architectures. Our focus is around explaining how we can use products in a way to solve customers' business problems. We do have a session next week at the general OpenShift Commons meeting to talk a little bit about validated patterns, but we're open to exploring any number of use cases. And with me today, we have two folks talking about a very cool AI pattern that's being created. And I'll turn it over to Swati and Saurabh.
Yeah, let me share my screen first, then I'll start with the introduction. So can you see my screen and hear me well?
Yes.
Okay. So, yeah. So hello, everyone, and thank you for joining us. My name is Swati Kale, and I'm an engineering manager with Ecosystem Engineering team. I work with OpenShift AI partners with various engineering initiatives, which mainly include solution building and integration. So today we will talk about one of the solutions, a validated pattern deployed by our team. It is based on LLM on OpenShift demo. It generates Red Hat product proposal for given customer. And my team member, Saurabh and Mikhail are among the main contributors to it. I will pass it over to Saurabh for his introduction.
Yeah, thanks, Swati. My name is Saurabh Agarwal, and I'm the lead architect in Ecosystems Engineering team at Red Hat. This is the application that we have created to do a project to showcase a project proposal using RAG and LLM. Using validated pattern, it makes it easy to deploy on an OpenShift cluster. So back to you, Swati.
Yeah, so Saurabh will also help us with the demo today. So for those who are new to validated pattern, it's a reference architecture for consistent deployment of application from GitHub repos to hybrid clouds. Basically, a GitOps-based framework which will automatically deploy a full application stack on your cluster, OpenShift cluster. These are validated and tested architecture and are a great starting point for customers and partners integrating their products and services. So in a nutshell, anyone can create a demo or use case of certain set of products and technology and deploy with GitOps. So today we will be covering demo description, what components are involved, how they are deployed, and their purpose. Overview of demo architecture. Saurabh will demonstrate the end-to-end workflow and deployment. Then we will summarize what we have covered today and take any questions. So what does this pattern do? It will deploy a chatbot application that will use retrieval augmented generation technique, also known as RAG. It uses proprietary data, which is any product documentation, to generate a project proposal with LLMs or models. The key business drivers over here are using LLMs for document generation by augmenting the model with domain and enterprise specific content. Compare between the different models and choose the one based on your business needs. For that, we monitor different models and evaluate their resource utilization and performance. Everything is managed through automated deployment using GitOps on OpenShift. So in the slide, you can see an overall architecture of the demo. Our core resides in GitHub. We are leveraging OpenShift GitOps, as I said in earlier, to automate the deployment of various application components, including front-end, vector database, model server, and monitoring stack. UI is simple chatbot, which is based on Gradio. Application is augmented with content from Red Hat product documentation. So we are also using Redis here as a vector database to store embeddings for those product documentation. We have job for document ingestion. We'll cover that in the next slide. The application over here can be A/B tested with multiple LLMs from various providers. We have tried with OpenAI, Hugging Face, and NVIDIA. And monitoring stack is based on Prometheus and Grafana dashboard to show model performance and response time. We also monitor user feedback in the form of star ratings for given models to compare between the multiple models. So ingestion. So document ingestion is certainly one of the crucial steps in the LLM RAG pipeline. Business data, maybe in the form of PDF or web pages, are stored and accessed from a storage bucket or GitHub repos lying in cloud or on-premise. We are using LangChain and Hugging Face, which are Python-based tools and libraries. So in the process, we use them to split documents into small chunks, create the embeddings from those chunks. Basically, it's a numeric representation of these text chunks and store them in a vector database, which is Redis over here. So in this slide, I will talk about the workflow of how user query the LLM. User query is captured through the chatbot. Then it is converted into the embeddings with LangChain APIs. These embeddings will use to retrieve the context from the vector store using semantic search. Then the query is augmented with the context from the vector store and is sent to the LLM to generate the response back to the user. So this diagram will combine everything together, which we have discussed already in previous slides with respect to data ingestion, user interaction, query, serving request response, and monitoring. So altogether, nothing but a RAG pipeline. So now it's time for demo walkthrough, and I will let Saurabh to do that.
Yeah, thanks, Swati. Before we deep dive into demo, we'll do a quick demo walkthrough. In order to deploy the validated pattern, you will need a GitHub account to fork the RAG LLM GitOps repository. You will have to bring your own GitOps OpenShift cluster. Currently, this pattern is supported on AWS cloud only. We are working with other cloud providers. You will need access to GPU nodes to run Hugging Face text inference server. The TGI server will serve the community Mistral 7B model. So here we'll start, go back to the previous slide. Yeah. So here we'll start creating a machine set. The machine set will provision nodes with GPU and configure them with NVIDIA drivers. Next slide. So now what we'll do is we'll run the make install command to deploy Argo CD and RAG LLM components. It will deploy Grafana dashboard and Prometheus for monitoring. It will deploy a chatbot application built on Gradio. It will also deploy a Hugging Face inference server, a Redis vector database, and a Kubernetes job to populate the product docs in form of embeddings into the vector database. So now we'll fire up the front-end application. This is the chatbot to generate a project proposal document using the RAG content from the vector database and LLM served by the Hugging Face inference server. So next is we'll have a dashboard to visualize the performance of inference server, application, and rating provided by users. With this, let's dive into the demo. So let me share my screen now. I'll take over from Swati in sharing the screen. Because let me know if you can see my screen.
Yes, we can.
Okay. As I mentioned, the first thing you need to do is you need to fork that repository and then clone the repository on your laptop or computer. Then CD into the RAG LLM GitOps directory. And the first thing you will do is to run this command, pattern SIG make create GPU machine set. We have automated the creation of the GPU machine set. So what this will do is it will run an Ansible playbook. And that Ansible playbook will deploy or create a machine set on your OpenShift cluster. The result of that, it would create 3 given required number instances of machines. These machines that are provisioned are tainted so that the workload that would require or are GPU intensive would run on these nodes. So this process will take around 10 to 15 minutes to complete. What we can do is now we can launch into the OpenShift console or log in into the OpenShift console and navigate to the machine sets. Here we see that the GPU machine set is created, and the instance that we specified in the machine set are 3. So 3 of the 3 machines are running. The instance type of this machine are G52X large, which are A10, which are NVIDIA A10 family with 8 vCPUs and 32 gig of RAM. So we can now navigate to the nodes and see that these nodes are running. They are in ready state. They have been labeled with ODH notebook for easy identification. And it has deployed around 20 pods, which will include the NVIDIA pods and the drivers. So now is the time to deploy the actual application. So in order to run the actual deployment of the application, we'll run the pattern sh make install command. What it does is basically first installs the Argo CD application, and then the Argo CD application uses the configuration in the validated pattern to deploy the various components, which will include the LLM monitoring component and the RAG LLM application with TGI server and all that. So after this process also will take around 10 to 15 minutes to run. We can launch into the Argo CD. We can launch into the Argo CD dashboard to monitor the deployment. Here we see that it has deployed this NVIDIA network operator, which is in healthy state and is all synced up. It has also deployed a RAG LLM application. This RAG LLM, this is an Argo CD application, so you can have multiple components as part of this Argo CD application. In this RAG LLM application, it has deployed the inference server in the Redis database. It has deployed your Gradio UI and also a vector DB job, which actually populates the vector database. So what we can do is we can actually now check the deployment of the pods. So go ahead in pods. The pods are created in the RAG LLM namespace. So here we see that our HF text generation inference server, this is the model server that's running. And it has deployed a Redis database, a Gradio UI, which is a chatbot application. And it has completed this Kubernetes job. What it does is basically it takes the documents uploaded in a GitHub and it creates a vector embeddings out of those documents and then populates the Redis vector database for semantic searching. So once we have we got this up and running, we can launch our application. We have created this menu item for easy access. So using the retrieval augmented generation menu item, we can launch the UI. So this UI contains an option to select a provider. So these are the LLM providers that a user can use. You have the capability to add additional providers. Currently, we support 3 types of providers. One is Hugging Face, the other is NVIDIA, and the third is any compatible OpenAI providers, right? So user can enter the customer name. We can enter, like, let's say IBM, and product is Red Hat OpenShift AI, right? And click generate. So it's using the inference server that it deployed to generate this project proposal. In order to generate this project proposal, we have created a prompt template, right? And that prompt template is used to do a semantic search against the vector database. And the content that it retrieves from the semantic search, it then augments that content with the query and sends the request to the LLM server to generate the response. In this thing, it is a project proposal, right? It also has created the sources, mention the sources that it has used to generate the project proposal. So these are the documents that actually it found during the semantic search, and then content from this document has been sent to LLM server. There's a download as PDF button, so you can download this this proposal in form of a PDF. The proposal that was generated was in Markdown language, so it looks much better when you look into PDF format, right? Yeah. What other thing you can do is basically add another provider, right? Like I have added a NVIDIA provider here. What you do in order to add a provider, you click on this Add Provider button, right? And what it needs is the type of provider, the model name, the URL, and the API key to access the server. What NVIDIA has done is basically they've created this sandbox application where they've hosted different models. And what you will need is the base URL, the API key, and the model name, right? Right now, you can generate the API key using the Get API Key button. You click on that, and it will give you an API key, which then you come back to your chatbot application, and you can provide this information here and click add. I'll not do that since I've already added up NVIDIA provider. What we also support is something called weightage. So this weightage you can provide like an integer number, and we can run this application either to display all the providers and let users select the provider, or you can change it to round robin, where the user would not know what are the different supported providers are, but they would be presented with one provider based upon the weight, and it could be used to do the round robin testing, right? We can go back to our chatbot tab and select this NVIDIA provider, and we can hit generate to generate the project proposal. Now this is this time this is using the NVIDIA provider LLM hosted an NVIDIA sandbox to generate the project proposal, right? And we can see that the uses the same sources to generate the project proposal. Again, you can click on the download as PDF to visualize that in the PDF format, right? The user can have the ability to rate this model. So if you are doing like sort of A/B testing and you ask your users like which model is performing better, they can rate the model. So let's say we rated this model as 5. All right. This rating is captured. This rating is captured as form of matrix, which can be visualized on the Grafana dashboard, right? So we can go to we can launch the Grafana dashboard again from this. We can launch this Grafana dashboard from the Grafana UI for LLM ratings, right? Okay, and to manage LLM monitoring. So you could see, you can view the response time of your inference server. This would be beneficial if you are running different inference server, right? Right now, currently, I'm running only one inference server. The other one is basically I'm directly accessing over the internet, right? So the NVIDIA one. So if you have multiple inference server, you can visualize the response time from the inference server. Also, you can visualize the response time of your Gradio application, right? And then the ratings, right? So here it shows the average rating, how many users gave the 5-star rating or how many users gave 4-star rating to what model. This is pretty dynamic. Like you can add any number of models there in the UI, and based upon the model name, it would pick up and display, it would add them into your Grafana dashboard. So that's basically, I would say, concludes my demo. If you have any questions, I'll pass it back to, I'll stop sharing and I'll pass it back to Swati for further. Um, yeah, Swati.
Yeah, so hope you are still seeing my screen. Thank you, Saurabh, for a demo. So by this time, we explained the validated pattern we created, had
Swati,
overview
we're
of the,
not seeing your screen.
not,
I think you need to
okay.
reshare.
I think I didn't, I stopped sharing, I guess. Yeah. Okay. Okay. So yeah, so now you can see. Okay. So I just want to summarize what we have done. We have explained the validated pattern, gave the overview of an end-to-end workflow and various building blocks for the rack, and also looked into the actual deployment and the application and the Grafana dashboard over here. So it's time for question and answers. So please feel free to raise your questions.
Also, you can post your questions on the Slack channel, and if not here, then we can answer, your questions on the Slack channel.
Benjamin, do you want to ask your question? I see you posted it in chat, but I mean, might as well just ask it directly.
Yeah, my question is, in the future, would the cost of inferencing be something that you want to pull out, or is that possible, or how would you be able to get the cost of running the different models?
Right, and that's a good question. What we are looking into, like enhancing our Grafana dashboard to show the tokens that were being sent to the server and the tokens that were received back, which would be basically can be used to give an some clue on the cost that it would take for inferencing. Currently, we are using this model running on our OpenShift, right? OpenShift AI can also deploy these models. So we are not experiencing that actual cost of the tokens at this point. But yeah, we can show the number of tokens that were being used, for this chat application. That would be helpful.
I put a question in the chat.
Yeah, I saw that question. Thanks, William. I mean, the advantage of using validated pattern framework, right? The biggest advantage lies in the GitOps framework, that it automates the infrastructure as well as the application deployment, and not just the deployment, but it also lets you manage that, right? So any drift during the application that occurs, it's a GitOps. It uses GitOps to drive this thing, the deployment, so it maintains your state always healthy. So that's the biggest advantage we have seen. It was actually very easy to assemble. Your validated patterns has it's a framework, right? So it gives you just put in your Helm chart and there you go, right? I mean, it takes like a day to bring up this infrastructure to deploy on OpenShift. If you look into this current deployment, what all we covered, right? We covered the creation of GPU machine set, right? The user does not have to get involved into all those things and making it correct, setting the right labels, setting the right toleration taints. We created this validated pattern and it just did it in 15 minutes. Everything was up and running for the infrastructure to be used, right? So I think that's a great advantage of using validated pattern. It also a reference architecture. So in order to basically how to do it right? That's actually is the proposal from validated pattern, right? It creates an architecture that can be reused and reused to replicate this deployment, and make it work. Question is, have you tried to scale? How many models? Right. So that's actually we are going to do in our next iteration. Right. We are actually moving it to use OpenShift AI. OpenShift AI is evolving as well, and now it has supported this KServe. KServe, we can use KServe to deploy these models, and it provides the way to basically auto scale these model servers, right? So that's basically we are going to in our next iteration, we are going to use the OpenShift AI and make it more seamless to deploy this application and auto scale the servers. Thanks for the questions.
Vault. So
Any
are
other
you using
question?
Vault for your secret for Hugging Face and NVIDIA?
Yeah, actually, we have not used the vault at this point. What we did was we created we are using the community model, which does not require a secret, but we want to actually give the user the ability to use any other models, like Mistral model, which would require a secret to download, or the Hugging Face token to download. And yes, we would be doing it in our next iteration as well. For NVIDIA, we did not need a secret, using the validated pattern, because this was the connection that we created on, using the chatbot application. So we did not use the secrets there. But we do have a configuration file where we actually have just added one default validated, just default inference server. Since we have deployed it locally, we did not put it behind the authentication, or it does not require an authentication. But yes, we can use if we have to use the configuration file with the secret, then we can use the vault to do it. And it's a very good support that all you need to do in validated pattern is just to put your secrets in vault, and the validated pattern deploys a external secret operator, which would sync your secrets from vault into your application, and you don't have to do any management. So that's a great feature from validated pattern as well. Thanks for asking those questions. Now, next question is, have you found a balance between model size, performance, results? This is, we did is like more sort of a demo here. Definitely, model size, we have used the 7B because we are restricted to the GPUs, right? We are using the G5 X large models. We cannot run like models which are like bigger than that. So it's like really we're not able to do those type of comparisons, in our demo. But yeah, we'll provide all the like matrix in Grafana, which can be used if we have proper nodes. Let's say tomorrow we want to provision a node with P4 or P5 on AWS. That can run bigger models as well, and can help evaluate those performance. Any questions? And guys, thank you for all these wonderful questions.
Such a great demo. Thank you for going through this. Everyone, at least in the chat here, is showing their appreciation. For those who are just joining or just at the recording session, this is going to be on YouTube later today or tomorrow, but you should see this recording for this session and all the other ones that we have. And if there any more questions before we wrap up? I'm assuming not. That was a great session and a lot of really good information. So thank you, Swati and Saurabh, going through this. This was great.
Yes. Thank you, everyone.
Thank you. Have a great day.
Thank you.
Bye.